Good afternoon, everybody. Welcome back to the Making Links series for C10. We're going to ask ourselves an important question in this video. How do we shift equilibrium? Now, it's worth taking your time to listen to this video to get these ways straight in your mind, because it can come up on paper 4 quite a bit. And if it comes up on paper 4, then you're probably looking at a good 6, 8, or 10 marks for shifting equilibrium questions. So it's really worth making sure that it's hammered down in your brain. Let's take our reaction from the last time where we looked at equilibrium. We'll just take a simple A plus B makes C and D. Now, if you understand Le Chatelier's principle that a chemical reaction will work to counteract any changes that you make, that's fantastic. If you understand that, this is just an application of Le Chatelier's principle. However, if you are feeling that that's a bit too complicated for you, if you don't want to get bogged down in Le Chatelier's principle, that's absolutely fine. Learn some key facts. And if you learn some key facts, you can apply them to any situation that they give you in the exam and still score marks. So it's worth just simplifying it down in your brain if you are finding it difficult to understand. These 2 key facts will help you. Increased temperatures favor the endothermic reaction. So if you raise the temperature, it will favor the endothermic reaction. Now, you won't have to remember which way is exo or endothermic. It will tell you in the question. So you just remember these 2 key facts. The opposite is true. Decreased temperatures will favor whichever way the exothermic reaction is. Let's have a look at it in practice and see if we can apply this understanding. But if you remember these 2 key facts, you'll be fine. This is the kind of question that can come up. It says the following equation represents the equilibrium in the contact process. Sulfur dioxide as a gas plus oxygen makes sulfur trioxide. Now, it doesn't matter if you don't understand the contact process at all for this. Actually, we will look at it later on in our learning, but it really doesn't matter if you don't understand it. We're just applying those 2 key facts. It says the forward reaction is exothermic. So if I were you, I would underline this fact, or I would write exothermic and draw an arrow this way, because that's very useful information in the question. It says the reaction is usually carried out at a temperature between 450 and 400 degrees C. It says, what is the effect on the position of equilibrium of using a temperature above 450? In other words, if you increase the temperature, well, we know that increasing the temperature favors the endothermic reaction. In that case, have a look down here. It's worth 2 marks. Try and pause the video now and think, what would you write for those 2 marks? Pause the video. Right, hopefully you paused the video and you came up with your own answer. What is the effect? What are you going to get your marks for? Because it's a 2-mark question, get into the habit of drawing 2 bullet points straight away so that you know you are writing enough points. Bullet point number 1, increased temperatures favor the endothermic reaction. That's the key fact you need to remember. Point number 2 that you get a mark for. Equilibrium will shift to the left. Because the forward reaction is exothermic, it told you up here. So an increased temperature is going to favor the endothermic, so you're going to get more reactants. Now you can say equilibrium will shift to the left or the right, the left being this way or the right being this way. Or you can say will favor the forward reaction or the backward reaction. Either way is right, either way will get you the mark. Find what works in your brain and stick with it every time. In my case, I like to say equilibrium will shift left and right. So in this case, because the forward reaction is exothermic, equilibrium will shift to the left. That's it for this installment. We'll have a look in a moment.